Welcome everybody. Today we are going to start with our first chapter, that is Fundamentals of Computers. So let's start our session. As the name indicates, you are going to learn about the very basic concepts of computer. You will be learning about how to define a computer, what is the history of a computer, what are the basic components of a computer, the software and the hardware sections, etc. Let us proceed with our first topic, that is applications of computer. Applications of computer means the areas where we use computer in our day-to-day life. So the first thing is access and store information. So you will you can type information, you can save the data, and you can retrieve and access it later on. We use computer to watch videos, we use computer to listen to music, we play games, and we draw pictures, we search information, we access our Facebook and Twitter accounts, etc. We can shop online. You just have to sit in front of the computer and add your items to the cart and pay the bill online. Your items will be delivered at home. You can download ebooks. Nowadays, we need not go to the shop to buy books. We need not go to the library to borrow books. You can pay online and you can download the ebooks. You get free ebooks to read. You can sit at home and read. And you can write blogs also. You can recharge your mobile cards and you can pay bills online. You can pay your electricity bills online. You can pay your telephone bills online, etc. Now these are the common areas where we use computers in our day-to-day life. There are a lot more, but I've just mentioned the common areas where we use computers in our day-to-day life. Okay, let us proceed to the next topic, that is what is a computer. The word computer is derived from the word compute, which means to calculate, to sum up and to count. To define a computer, this is the point which we use. The computer is an electronic device capable of solving problems or manipulating data by accepting data, performing prescribed operations, that is mathematical or logical operations, on the data and supply the result of these operations as output. So the computer will be getting the data from us, that is we are the users. So computer will get the data from us, it will process it and then it will display the output. I've given you a pictorial representation at the bottom of the screen. Input, then processing and then information. So input is the area that is it gets input from the user, it does the process, it does some calculation and then displays output on the monitor or through the printer or through the speaker. Now can you see a bubble like symbol on the right side top corner? Charles Babbage is known as the father of computers. Now, why is Charles Babbage known as the father of computer? Because he invented analytical engine, which is the model of today's computer. Analytical engine worked with the concept of input, processing and information. So, this was the model of today's computer. Since he was the first person who gave us the basic idea of computers, we call him as the father of computer. Let us move on with the next topic, that is history of computers. There were many devices invented in the past era leading to the development of modern computers. So we directly didn't jump into the latest laptops or desktops or your tablets. So initially the very basic thing started with the idea of computer came, then a small things were developed, and then now as the generations passed, now we have come to the modern development has come to reach to the modern computer. So the first thing which was initially started was abacus. Abacus was the first known counting device in this journey. It was developed over 500 years back in the 3000 BC in China. It was made up of wooden frames, as you can see it in the image, which have it was made up of wooden frames having sliding beads over thin metal rods. So you can see the metal rods also and the small beads which are put up on it. So it can be used for addition, multiplication and division. Then in 1642, Pascal adding machine, otherwise called as Pascaline, was developed by Blaise Pascal. It was the first numerical calculator. This machine had gears, wheels and dials, as you can see it in the image. It had capacity to perform addition and subtraction. Then in 1671, Pascaline, that is the previous image, this Pascaline was replaced, modified by Gottfried Wilhelm von into Leibniz mechanical multiplier. Now this machine was capable of performing multiplication, division along with addition and subtraction. So you can see the difference now. Pascal was able to do only addition and subtraction, but this machine was able to perform multiplication, division along with addition and subtraction. Now then later Charles Babbage, this is the image of Charles Babbage, as I told you before itself. Charles Babbage was the father of a computer. So he invented two mechanical devices, which is difference engine in 1822 and an analytical engine in 1833. Now these machines had stored programs and could perform calculations and print results automatically. Now programs, if you want, and just take up an example of a calculator. We just know that we enter we can enter a single digit number or 2-digit number or a 3-digit number or a 4-digit number, and it performs an operation. It performs addition, multiplication, division, everything, and then it gives you the result. You just give the input to the calculator, 2 plus 4, and it gives you the output as 6. So it gets the input 2 and 4, it does the operation, and then it displays the output 6. Right? So this is how it works. So it has been programmed already inside the calculator that whatever it has to get the input, and the key whichever they use, the multiplication, the addition, whichever key they use, that operation it takes, and then it does the operation and it gives the output. So programming concept was started with this analytical engine. So that is why he was called the father of computer. The next is about punch cards. Punch cards were first successfully used with computers in 1890 by Herman Hollerith and James Powers. They developed devices that could read the information that had been punched into the cards automatically without human help. Now, as you can see an image of a punch card at the left side corner, these punch cards are little thick paper strips, and a machine is used to punch these data on the card, and then a bunch of cards will be placed on another machine from where the computer will read the data, and it does all the process, what and all operations has been mentioned in it, and it does it, and then it gives the results to the user. Next is in 1946, two scientists, J. Pressburg Eckert and John Macaulay, invented the first high-speed electronic digital computer known as ENIAC, the electronic numerical integrator and computer, and it occupied the entire 30 by 50 feet room. As you can see it in the image, you see how big it is. Okay, so and the ENIAC was therefore about 1000 times faster than the previous generation computer. ENIAC used 18,000 vacuum tubes. You can see an image of a vacuum tube on the right side. ENIAC used 18,000 vacuum tubes, and it used 1,800 square feet of a floor space and consumed about 180,000 watts of electric power. So you can understand from this that how much space it used. It used lot of space, lot of electrical supply also. So this was the first generation computer. Then in 1950, these vacuum tubes which you saw was replaced by transistors. Okay, and then next improvement in that was next generation computers came. The improvement in that was the RAM space, the RAM capacity was improved, and then in 1980s semiconductor chips was developed, and in late 1980s we got a PC. First a PC, personal computers were run by microprocessors that handle 32 bits of data at a time. As you can see an image at the bottom here, see first generation had that vacuum tube, then the transistor came, then third generation the transistor itself, next development came, then it came like this. As now you can see, even in TVs you would have seen Intel Core i7. These are the images now. So till now we have 5 generations of computer are in existence, and each generations of computer some improvement, next level of improvement was there. So improvement in speed, storage capacity, reliability and accuracy was improved in each and every generation. So now we are in 5th generation. The modern computer are here. We are using laptops, we are using tablets, we are using desktops with high speed. So initially how it was, and now there is a lot of change. Great improvement is there. So this is all about history of computer. Components of computer. Now components of computer are categorized into two, that is hardware and software. Hardware are the parts of computer which you can touch and feel, and whereas software are the programs which are installed within the computer. Now, hardware consists of input devices, output devices, central processing unit and storage unit. Whereas software has is categorized into two, that is system software and application software. System software is again categorized into operating system and processing programs. Application software is again categorized into general purpose software and special purpose software. So, let us proceed with the hardware components. The first subtopic under hardware components is input devices. The most common input devices which all of us would have used are keyboard and mouse, without which I don't think a computer can work. These are the devices which are used to enter instruction or feed data into the computer. Input unit accepts these instruction and data from the user and converts these instruction and data in computer acceptable formats, which are sent to computer system for processing. Now, computer doesn't understand English directly. So, what happens when we type something in English? It is converted into something which computer can understand and then it is processed. Now, let me just explain you this with an example. Assume that there are two people who want to communicate to each other. The first person can speak and understand only English, and the second person can speak and understand only Hindi. Do you think will they be able to communicate with each other? No. Hence, they need a translator to translate what the first person is trying to communicate to the second person, or what the second person is trying to communicate to the first person. So, in the same way, in computer also, when we type something using the keyboard or when we give any input to the computer, computer doesn't understand that language. It understands only machine language. So, that language, that is the English, is then converted into a language which the computer can understand, and then it processes the data. Clear? Let's proceed with the examples of input devices. As I told you earlier, keyboard is one of the most common example of input devices. The data and instructions are input by typing on the keyboard. So, when we type something on the keyboard, the data, that's how we give input to the computer. The messages typed on the keyboard reaches the memory unit of the computer. So, whatever we type on the keyboard, that goes to the memory unit of the computer, and from the memory unit only it goes further to the processing area. Apart from alphabets, numerical keys, it has other function keys for performing different operations. Now, as you can see on the screen, we have alphabets, numbers on our keyboard. Other than this, apart from this, we have the first row, that is F1, F2, F3 till F12 we have. These are called as functional keys. Function keys, and these keys have its own function, preset functions. Next example is mouse. It is a pointing device. The mouse is rolled over the mouse pad, which in turn controls the movement of the cursor in the screen. You can click, double click or drag the mouse. Its sensor notifies the speed of its movement on the computer, which in turn moves the cursor or pointer on the screen. So, when you move your mouse on the mouse pad, so with the movement with which the movement speed with which we move, accordingly the mouse moves on the screen also. Next example is scanner. Scanners are used to enter information directly into the computer memory. This device works like a Xerox machine. The scanner converts any type of printed or written information, including photographs, or into digital pulses, which can be manipulated by the computer. So, scanner is, I guess all of you would have seen Xerox machines, how it works. You have to place the content facing the glass on the Xerox machine and then scan and print it. That is how a Xerox machine works. Same wise, the scanner also works. You have to place the content facing the screen, that is a glass on the scanner, and then cover the lid and scan it using the software installed in the computer. So, as soon as you scan, the data is converted into a digital format and you can see the content on the screen. So, any paperwork, any hard copy, in a photograph or any written work or any kind of documents, we can scan it and then we can convert it into a digital format, and then if you want, you can edit it later on. Light pen. This you can see an image on the right side. This you would have seen even in your e-classrooms. e-pad and with a pen. That pen is called as a light pen. This is an input device which is used to draw lines or figures on the computer screen. So when you write something on the e-pad, you can see you are giving input to the computer. The input, you can see it on the screen. Whatever you're writing on the e-pad, you can view it on the computer screen as well. Next is barcode reader. This device reads barcodes and converts them into electric pulses to be processed by a computer. You would have seen these barcodes in your school library, or you would have seen this in supermarkets where they use these barcodes. Barcodes are these, you can see it on in the image also on the right side. Thin and thick black lines which is scanned using the barcode reader is used to scan these bars. When you scan, you would have seen it in the supermarket. When you scan it, the content, that is the product name and the amount of that product, appears on the screen automatically. So it makes our work much easier. Next is output devices. These devices are used to get the output in human understandable format. As I told you, for input device, the data which we give to the computer, it doesn't understand that language. So it has to be translated into the language which machine can understand. That process is done within the computer. Likewise, after the process is done by the machine, it is still in the machine language format. Then it has to be converted into something which we can understand. When we understand English, it is then translated into English. So the first example is monitor. The monitor looks like a television screen. It is also called visual display unit. It is used to display information from the computer. So whatever data the computer, whatever process the computer does, that has to be viewed by us. So the monitor helps us in viewing all those data. Based on the technology used, monitor is classified into two categories: cathode ray tube monitor and liquid crystal display. The image which you're seeing on the screen now is a liquid crystal display monitor. CRT monitors are also used now, but they have reduced the usage now because more power consumption is there with cathode ray tube, whereas in liquid crystal display it is more clear as well as power consumption is less. Next example is touchscreen. This is something which all of us have used. Mobile phones with touchscreen or touchscreen computers are also there. So touchscreen works as both input and output device. When you touch on the screen, it is the input which you are giving to the computer. The computer will accept the data wherever you touch. According to that, the operation takes place, and then the result is displayed to us on the screen itself. So this touchscreen acts as a both input and output device. Next is a speaker. Speaker is an output hardware device that connects to a computer to generate sound. The signal used to produce the sound that comes from a computer speaker is created by the computer's sound card. So if a computer produces a sound, that means it has a sound card within. The next example of output devices is printer. Printer gives a permanent output onto a paper instead of a computer screen. The output given by a printer is referred as a hard copy or a printout. So something which is printed on the paper using a printer is called as a hard copy, and something which we see within our system is called as a soft copy. Printers are broadly classified into impact printers and non-impact printers. Impact printers, printers that work by banging a head or needle against an ink ribbon to make a mark on the paper. So when we use impact printers, every impact printer has a head or needle like thing with the ink ribbon in front of that head or needle. With an impression, it prints on the paper. When it bangs on the paper, it produces a impression on the paper. So the impact printers are further classified into line printers and character printers. Line printers are printers which print line by line on the paper at a time. It will print one line. So the example of line printers are drum printer. Character printer. Character printers print a character at a time. The print head contains a matrix of dots. Dot matrix printers is an example of character printers. As the name indicates, character printers, it prints character by character. So all your alphabet, numbers and your special characters like @ ampersand, $, hash, these are all called as characters in computer. So it prints let that be alphabets 1 to 3 or special characters, one by one it will print. Whatever data has to be printed, accordingly it will print character by character. So dot matrix is an example of character printer, and it uses dots to print the characters. Non-impact printers. It is a type of printer that does not hit or impact a ribbon to print. So unlike impact printers, non-impact printer doesn't hit anything, or it doesn't produce any impression on the paper. The paper will be smooth, neat and clean with the printout. Two most commonly used non-impact printers are inkjet printers and laser printers. Inkjet printers uses ink cartridges. As you can see an image on the right, a printer image is also there, and the cartridge which is used within that printer is also there. So these are the cartridges which are used within that image. And an inkjet printer, how it prints, the cartridges move across the paper in the printer, and it sprays ink and prints the data wherever it is required. So if a letter is being printed throughout the paper, wherever the characters are there, the cartridge will move across the paper and it will print the data on the paper. Laser printers. Laser printers use toner cartridges. As you can see an image on the right, there is an image of laser printer and the toner which is used within the laser printer. Laser printer uses an electrical charge to instruct where and when the toner should be dispensed on the paper. Now laser printer uses powders within the toner to print, whereas inkjet printers uses inks within the cartridge to print. So using an electrical charge, the toner is instructed where it has to use the heat and use the powder to print the data on the paper. The next subtopic under hardware components is Central Processing Unit, CPU. The main unit inside the computer is the CPU. This unit is responsible for all events inside the computer, and it consists of two sections, that is Control Unit and Arithmetic and Logic Unit. The CPU is the brain of a computer system. In a human body, all the major decisions are taken by the brain, and the other parts of the body functions as directed by the brain. Similarly, in computer system also, all the major calculations and comparisons are made inside the CPU, and it activates and controls the operation of other units like hard disk, printer, etc. of a computer system. CPU consists of two sections, that is Arithmetic Logic Unit and Control Unit. Arithmetic and Logic Unit is the section where all the arithmetic operation takes place, that is addition, subtraction, multiple division over data received from the memory. And Control Unit, it obtains instruction from the program stored in the main memory, interprets the instruction and issues signal that cause other units of the system to execute them. So it gets the instruction, it understands, it interprets, and then it instructs the other units of the computer to do that operation accordingly. And the control unit directs and controls the activities of internal and external devices. Next is storage unit. As the name indicates, storage unit is used to store something, okay, store the data. The data and instructions that are entered into the computer system through input units have to be stored inside the computer before the actual process starts. So when we get input from the user, that has to be stored somewhere inside the memory, inside the computer, that is in the memory of a computer, and from the memory it is given again to the CPU to do the process, and from CPU again it is stored inside the memory, and from the memory again it is given to the output device to display it on the screen or print it out through any output device it is given. Let us learn little deeper about the storage unit, that is the memory unit. Computer memory. The memory unit is an essential component in any digital computer, since it is needed for storing the data and programs that are executed by the CPU. This is the block diagram of the process which happens within the computer. that is we get input from the user, that through input devices, that is stored in the memory first here, and then from the memory it is given to the CPU. The CPU does the process. Again from the CPU it is given to the memory, and from the memory the data that is the final information is given to the output device, so that it could be displayed to the user using screen monitor or any other output device. There are two types of memory, that is primary memory and secondary memory. Primary memory is otherwise called as main memory. The primary memory is the computer's work area. It is also known as internal memory. Now when you type, for example, if you are typing something on the computer, say if you are using a Word document to type a letter or any project or any assignment, when you are typing something, at that time the data is stored in the main memory, that is your primary memory, random access memory. And once you complete your project and once you click on file and save, it gets saved in the hard disk, that is the secondary memory. So something which is in the primary memory can be accessed faster when compared to the secondary memory. So what with the data which you are typing will be initially stored in the random access memory, that is read-only memory, otherwise called as the primary memory. And once you complete your typing your data, and it is saved in the hard disk. Okay. Secondary memory. Programs or data not needed immediately may be kept in offline or secondary storage until needed and then brought into the main memory for execution or reference. Like if you have saved your data in your hard disk, and again next day if you want to retrieve the data, again open the same file and you want to continue typing, you can retrieve it. Again you are bringing from secondary memory, you are bringing back into the random access memory, that is the primary memory, and so that you can quickly work on it. Secondary storage devices are of two types: magnetic and optical. Magnetic devices include hard disks, and optical storage devices are CDs, DVDs, pen drives and others, etc. I hope you all are clear about the hardware components. So let us proceed with the next subtopic, that is software components. What is a software? A computer cannot do any work on its own, so it is dependent on us. The instructions which we give to the computer, only with those instructions the computer performs all the operations. So these set of instructions required for running a computer system and to process information is known as software. What are the types of software? System software and application software. The system software is again categorized into two, that is operating system or control programs and processing programs. Application software is again categorized into two, general purpose software and special purpose software. This is a diagrammatic representation of types of software. Hardware, as I said earlier, these are the parts of computer which you can touch and feel: CPU, disk, mouse, printer, etc. And to make these hardware work, we need to install system software. And after the installation of the system software, according to the user requirement, the application softwares are installed. So operating system acts as an interface between the application software and hardware. For example, say application software, system softwares are operating systems which is required for the system to work. Without an operating system, a system cannot be started, it cannot be worked. And once you install the system software, application software has to be installed according to the user requirement. For example, if we want, most common thing which all the system have is Microsoft Office. So if I want to type something, say if I want to prepare a PowerPoint presentation, if I want to use Word document for typing some letter, or any Power project has to be typed, or any Excel file in which I want to do some kind of calculation, for that I definitely need a Microsoft Office application software. So other than this, say if I want to play games, again I have to install the software for game. Then again if I want to say record something like the one which I am recording now, again a separate software has to be installed for recording this. So according to the user requirement, the softwares are installed. So I hope this diagram is clear. Next, the system software. It consists of general programs designed to control the operations of computer systems. So as I said before, system softwares are the general programs designed to control the operations of computer systems. So two types of system softwares are control programs and processing programs. Control programs, these system programs take care of all the system activity and handle all input, output, job scheduling, etc. So as I said before, operating system is the example of control program. Now when an operating system is installed, operating system acts like a medium between you and the computer. It acts as an interface between the user and the hardware. So whatever you're trying to communicate to the system, say if you're through input you're typing something, that data is given to the computer to process, and everything is done, and once the data output is also displayed on the screen using the help of operating system. So it is the medium between you and the computer and the hardware. Processing programs. These programs work under the supervision of operating system. These help application programs to do actual data processing. So there are two types. The first one is language translators. As I said earlier, the language in which we type, that is in English, when we type something, the computer cannot understand this English language, and this English language, the language in which we type, we call it as high level language in computer, and this high level language has to be converted into the machine language so that machine can understand. So the language translators are used to convert this, to translate this program into machine language. Next is utility program or service program. Utility software is system designed to help analyze, configure, optimize or maintain a computer. Like we maintain our home, we clean our home daily, and we do that on a regular basis. Daily we clean our home. So that's how we maintain our home. So likewise, in a system also we need to maintain the system. So some software, some programs are required to maintain your system also. So these set of programs which execute tasks frequently required in data processing. These tasks are of routine nature that all computer users need to perform by their machines from time to time. So for example, backup utility, we need to take backup of our system, and say if something happens, some system corruption or something happens, the system restore option is there, so we can restore back our system to one day before, or say 2 days before, a few hours before. Options are available. And antivirus is again used to maintain our computer. Say virus, to protect our system from virus infection, we have to use antivirus. Application software. Application software includes program or set of programs written by end user. So there are two types of application software, that is general purpose software and special purpose software. So the general purpose softwares, a good example of general purpose software is Microsoft Office. Now Microsoft Office is an application software which is commonly used by everyone. The people who use computers, say they will definitely want to type something, a letter or any project or any assignment or anything in a Word document. They would also want to prepare a PowerPoint presentation. They also want to use Spreadsheet. These are all common general purpose software. So these are softwares which are generally designed in general so that everybody in common can use it. On the other hand, special purpose software, these are software which are specifically designed for only for one particular purpose. So for example, say some accounting work, not everybody is not going to be involved in accounting work, and reservation system, everybody is not going to work in reservation system. Everybody have different jobs. And say for example, you can take up an example of library management. Books are only in the library books are going to be used. So books are going to be used in large amounts. So they definitely need a software to maintain those books. Say if a book has been issued to one child, then the remaining number of books, say a copy, say social science book is available, 10 copies of social science book is available, and if 5 students have taken that book and remaining only 5 is there, so that to maintain such stocks, library management software is required. So not everybody is going to use all the library management software. I hope you all are clear with all the concepts. With this, our first chapter ends. If you have any kind of doubts, post your comments. I'll get back to you soon. Thank you.